All right, we're good to go.
All right, welcome again, everybody. Just as a reminder, I'm Patrick Nolan. I'm the Director of Experience Studies at the Society of Actuaries, and this is part two of a two-part session. On yesterday's session, we talked a little bit about experience studies, what they are, why we do them, how they work, what you can get out of them, and finally, how to carry them out. And towards the end of the session yesterday, we teed up this concept of an Excel exercise where we would do something of a simplified experience study on a synthetic data set. So that's primarily what we're going to be doing today. I'm going to walk through how to set up the different calculations for the experience study. I'm going to walk through how to kind of set everything up, what things to look out for, that kind of thing. And I'm hoping that after introducing the exercise yesterday, that some folks have been able to kind of take that back and kind of consider the strategies that might be used to process the study. So just as a quick reminder, I'm going to bring back the Excel functions that we talked about yesterday that we think we're going to be using. Not going to do the detail from yesterday, but as a reminder, these are the options that are available to us that might be useful: if, trunk, date, month, day, not, round, year frac, and or, min, and if errors. So we'll just try to keep these functions in mind as we try to think through how we will go about processing the calculations. So I'm going to bring up that synthetic data. Hopefully this is large enough for everybody to see. And simply put, what we're trying to do is we're trying to come up with a tabulation of exposures and deaths for calendar year 2018. And using a series of columns that will create off to the side, some of them will actually be those calculations and some will just be helper functions that will allow us to kind of document what we've been doing and kind of observe our code a little bit more easily. You could certainly write the code to tabulate the exposure at each age in a single formula, but if you do that, it might be kind of cumbersome and difficult to follow. Not that hard to review because you'd probably be able to check for particular cases and make sure that they're all working properly. But if someone is trying to follow your work, it might be confusing to try to put all of the logic that you would need to actually do this properly into a single cell. So we're going to be breaking out the tabulations into a bunch of different helper columns that hopefully make it easy to follow what we're doing. So I mentioned at the outset that we are going to be tabulating exposure by age. So the first thing that we might want to consider is what is the age of each of these people during the study? And it's a little bit tricky because since we're doing this for a calendar year of 2018, each person has more than one age during the calendar year. So I think the idea would be if we're doing this as an experience study, is we'd probably want to just be able to tag each record with the ages that the person is during the year, and then we could aggregate that information with what's called a SUMIF function. And I think that we can maybe get to that towards the back end of this when I start talking about the solution and show how it's aggregated. But essentially, a SUMIF function allows you to conditionally sum up all of the exposure conditionally sum up all the exposure if the person is of a certain age. So that's kind of how you could take this seriatim information and translate it into a table. So with that in mind as the end goal, the first step, I think, is to try to organize and figure out what ages these people are during calendar year 2018. And I guess we'll just call them for the time being age 1 and age 2. I'm kind of a formatting geek, so I try to make sure that it looks kind of nice at the top there. So for age 1, maybe I'll just, and hopefully folks have this spreadsheet open on their computers. Maybe I'll just pause for a second and folks can consider how to go about determining what age this person is as of the beginning of 2018 using some of those functions that we looked at yesterday. So I'll pause for about, maybe like half a minute or so, and then we'll show how to go through this. All right. Well, I think that the starting point for doing this would be that year frac function that we were talking about, because that's a way to measure the time between two dates. So if I start off by saying year frac, and then I use the date of birth as one of my inputs, the second input is going to be the date as of the beginning of the year, because that'll tell us whether the person what the person's age is on January 1st, 2018. So if I want to punch 1/1/2018 into this formula, I have to use that date function. Put in 2018 1/1, right? All right, so this first person is 64.025 years old as of the beginning of 2018, but we want to know what so that we can tabulate this at the end. We're not really interested in what their exact age is at that date. We're interested in their age as of their last birthday, because we know we're going to be dividing the experience for calendar year 2018 up into the first age that they are and the second age that they are. So in order to do that, we're just going to amend our formula up here and ask it to truncate that age. And that's how we get 64 for the beginning of the year for this person for 2018. Just go ahead and copy this down real quick. And now we have repeated that formula for everybody in our spreadsheet. See a bunch of smattering of ages there. So that's the first place to set this up. Now we've been able to tag everybody with the first age. For the second age, we don't have to do anything quite as fancy because everybody has a birthday at some point during the year. So the second age is just going to be one greater than the first age. So this is much simpler. All right. So now we know what two ages everybody in this sample study is going to progress through as we measure their exposure for 2018. Now, now that we have the ages, we know we're going to tabulate the exposure for each of these ages. So essentially, we need to track the exposure in two separate columns because we have two separate age columns. So we're going to have exposure age 1 and exposure age 2, death age 1, death age 2. Because we're tracking the number of deaths, and the death count is just going to be 1 or 0 for everybody, depending on whether a death took place at the age in particular. So we're going to go ahead and wrap this, center this guy, bold it, highlight it. I just like having some formatting on here. So this is essentially the setup of our problem. And at the when we get to the conclusion of this, we're going to conditionally sum up the exposure and the death at each age, conditional on the age 1 matching whatever whatever age that we're trying to tabulate for, which is going to be all of them eventually. We're trying to create like a table of sample mortality rates at the end of the day. All right. So like I mentioned at the outset, it would definitely be possible for us to put all the logic that we could possibly want into these 4 cells and complete our experience study. But that sometimes can get confusing. It may be a little bit more error prone, and it's not exactly the best documentation in the world either. So I think we're going to have to, I think that off to the side, we'll create some new columns that we can reference in these cells to come up with our final exposure and death numbers. So the first thing that I want to consider is for the exposure age 1. The reason the logic gets complicated is that there are a bunch of different situations that a particular person could be in. You'll note that this set of experience study data is not only for calendar year 2018. You're going to find some people in here who aren't even alive during 2018. So we can't just do a simple formula taking like the fraction of the year from the beginning of the year to the birthday, because we don't know if the person's even retired or not. So I think that what we need to do is we need to consider the different possible situations that an individual can be in. So can anybody, and I'll ask the question aloud, of course I'll guide and go through if we don't get any responses, but can anybody suggest a possible scenario that would repeat itself for a bunch of records for a particular person. And maybe I'll just maybe I can start by teeing up the first one, and then we can move into the others. This first one would be putting this in the different color because that's going to be our helper column. So we'll call this exposure age 1 for a person who is not yet retired. Now, this is basically going to be this is a situation where we are going to be looking at a person whose date of retirement actually takes place after the person is no longer age 1. I'm going to go ahead and wrap this text. So in this situation, basically we would want to compare the date of retirement against the person's 65th birthday during the year 2018 for this first person. And if the date of retirement is later than that date, we know that they fall into this category and that their exposure at age 1 is ultimately going to be 0. So that's one possibility, that the person just is not retired yet by the time they are no longer age 1. Does anybody have any ideas for what might be another possible scenario for during this year, for during the period where somebody is of their first age? Well, I think one thing we can do is just look at maybe the simplest case where the person is actually retired during age 64 in 2018, and there aren't any event dates that get in the way of their exposure before they turn age 65. So this would basically be a situation where the person has had, either they retire um, either they retired like while they're age 1, or they retired before the beginning of the year. Either of those scenarios, but we don't have any sort of end date or date of death before the end of the year. So I'm going to go ahead and put this in. This will be exposure age 1, and this would be the scenario with no event dates. All right. So I can think of 3 other scenarios that could take place while the person is age 1, assuming that I'm kind of lumping the possibility where the person retires during age 1 into column N for this purpose. But you could just as easily put retirement in during age 1 into a separate column. Take any thoughts then for any of the other, we'll call it 3 scenarios that I kind of am thinking of my mind for what could be the case for this person during the year. Well, one of them would just be kind of what we're measuring, and this would be exposure age 1 for death. If we do observe a death while the person is their first age during 2018. And this, of course, will yield a little bit different results for exposure based on what we talked about yesterday with the event date that we're measuring and how that kind of factors into the exposure tabulation for the person, because it's a little bit more of a special case, and we'll be sure to review that today. 2 more I can think of. Any ideas which one would what another one would be here?
The benefit end date or the benefit?
Yep, yeah. So we have a situation where where the benefit ends. Very good. All right. And then one final possibility that I'm thinking of. Any guesses with what the last one would be? All right, here nothing. The last one in this situation would be the possibility. We covered the situation where they were not retired by the time that this age band ends. There's also the possibility that their benefit ended before this age band begins. So in this case, it would be the possibility that the benefit had already ended prior to 1/1/2018. And this could be a situation where there's a death beforehand. Or it could be a situation where in this case, since we're not measuring exposure for this exercise for years before before 2018, this would apply whether the person has either died or whether the benefit ended prior to 2018. So this would be exposure age 1, benefit previously ended. And this is kind of more of like a null case, like the first person. This is basically this column and the other column, this column M and Q. These are basically trying to figure out who are all the people that we don't really care about for measuring exposure for this year. So the way the data are kind of drawn up for the study, there's plenty of those in here. All right. So we've got our 5 possibilities for each person. So now I think that the goal becomes trying to figure out which subset of records falls into each of these categories and what the exposure is for each record that does fall into these categories. So for this one, this is probably the simplest one we have here, is for somebody who is not yet retired. So somebody who's not yet retired by the time that this person is no longer, let's say, 64 years old. So this person will turn 65 years old on December 22nd of 2018. And if the person, we know the person has retired before then, but should this date of retirement have been sometime in, let's say, 2019 or later in 2018 than their birthday, we would want this cell to show a 0. So what I kind of suggest doing here is to use blanks for the cells where the condition does not apply, and then numbers for situations where the condition does apply. So in that sense, there's a difference between a 0 or a blank popping into this field, because the blank tells us that this condition does not apply to the person. A 0 would tell us this condition does apply to the person and their exposure is 0. So one thing I'm going to do here actually is the birthday within the year is such an important helper figure to know for each person, and it would be kind of cumbersome to reprogram the date of birth each time you have to reference it. So what I'm going to do here before even beginning to look at the different scenarios is I'm just going to put in like a helper column here, and I'm going to call this birthday in 2018. So I'll let folks think for just a second about what function you could write to return the birthday in 2018 for each of the people in this file. As you might imagine, it's going to be another one of those nested type functions. So we will first we're going to define it as a date. We know our year is going to be 2018. The month is going to be the month of their birthday. And the day is going to be the day from their birthday. And that'll return for us, if I make this a little bigger, December 22nd, 2018. And just by copying it down, we can get this figure for every person in the file so that we no longer have to rebuild the person's birthday from scratch every time we want to reference it. Because this is a key stop date for exposure for age 1, and it's the start date for exposure for age 2, to the extent that the person is retired at the beginning of those age bands. All right, so now for exposure age 1, for somebody who's not yet retired, we can look at it like this. Basically, we want to see if they're not yet retired by the time they turn age 2 during the year, then we want to assign that person with 0 exposure because exposure has not begun until after they are no longer age 1. So I think this is one of the simpler formulas that we'll encounter in terms of tabulating exposure. So we're just going to say if D2 is greater than or equal to M2, because if the retirement takes place on the birthday, we'll consider them the next age. Then we'll return a 0 for the person's exposure because the exposure will be 0. And if that is not true, then we are going to just have the cell be blank. So you put in just like the 2 quotation marks to impute a blank. And by copying this down, trying to see if we can find some where the date of retirement's a little bit later. Yeah, this happens a little bit more later in the file because I think that there is some chronological sorting to it. But you can see for all these people who have a date of retirement well after the birthday in 2018, this column is returning a 0. And for everybody to whom that doesn't apply, they have a blank in there. And the way we draw this up, by the way, is if we do this correctly, we should wind up with exactly 1 column for each record that has a non-blank value. And that's by doing it this way and splitting it up into 5 columns, we'll be able to measure, we'll be able to make sure that our conditions are working properly by making sure that we can do just a quick check to make sure that exactly 1 has a value in it that is not blank. So that's a way you can kind of check your work on this. All right. So we can move on to the second piece, and this would be exposure age 1, and maybe I can just change the label here, retired and no event dates. So this is a situation where the person is retired for all or part of their first age, and we don't have any sort of benefit end date or date of death during that period. So I'll give folks a second here to just try to ponder this because there is quite a bit of logic that has to go into figuring this out. So maybe just take a second and think about what you would do to try to make sure that you're capturing the correct person type with your logic. All right. So this is going to be a bit more of a bumpy ride than the other one. Maybe first we'll just figure out. So this is a situation where we know the person has to be retired prior to the birthday. So the first part of our condition is going to be if date of retirement is less than the birthday, right? But we know that there are more conditions that need to be satisfied. In order for this specific column to apply, the benefit end date can't take place during this period, and the date of death cannot take place during this period. So what we would do is we would say change this first condition. We know it's going to be an and because this has to satisfy multiple things. We need to make sure that the next condition of the and will be to make sure that there is no benefit end date that takes place between before 12/22/2018 during the year. So there's a few different possibilities that could make this true. The first one would be simply, is this blank? Because if it's blank, it can't be there, right? The second possibility is that the benefit end date could be greater than or equal to the birth date, because if the benefit ends after the person is no longer 64, that would satisfy our condition. So we'll go ahead and close this out here because I think those are the 2 main possibilities. And I think that satisfies it. I think that's what we're looking for. So now that we've established the logic for what type of person will fall into this column. Oh, I'm sorry, I forgot one more. There's the death date. We have to do the same thing for the date of death. Almost slipped my mind there. So check if F2 is blank, or if F2 is greater than or equal to the birth date. Right. See, it's easy to forget things while you do this. That's why at Experience Study Coding and Process is quite a bit of review to make sure that you've got all your conditions set up properly. Okay, so what should our exposure be if the person is for exposure age 1 for somebody with no event dates like this? Basically, there's two possibilities here. Depends if the person is retires during the year, or if they were retired prior to the year. So I think that what we could do is, using the minimum function, we can say, okay, this is just going to be the difference between the date of retirement and the birthday, subject to a minimum of the birthday and the first of the year. And then if it doesn't satisfy the condition, our value if false, I know it's kind of small on the screen, but our value if false is going to be a blank. All right. And this is actually a condition that applies to this person. This is a situation where the person has no event dates. They were retired, before their birthday. So they get 0.975 years of exposure at age 64 during 2018. So at the very least for the first person, this seems to be working correctly. We'll go ahead and copy this down. All right. So moving on, we have the exposure age 1 in the event of a death. And this is kind of tricky as well, because there's situations in the data you can't just check to see if the date of death falls between the birthday and the date of retirement, because you could have a situation where you have a benefit that ends prior to the date of death. This happens all the time, where you have an end date and the benefit stops, but for some reason the person's information still remains on the record, and they wind up coming through with a death date at some future date. So I'm just going to do a quick filter here to see how prevalent this condition might be. This would be like one of the tricky cases that we would want to review our data for. So this would be, and this applies to age 2 more than age 1, since this person was born in February. But we have a situation where they're a long-standing retiree, and they have a benefit end date of May 22nd. So they are not in payment at the time of their date of death, and this would not be a person that we would want to observe. We would not want this person to be treated as a death. This would be a situation where they would hit the benefit ends condition. So with that little trick in mind, we can potentially, I'm trying to see what would be the most useful here, but this is a pretty big nested condition similar to the last one. So we're gonna put a pin in that one just for the moment. We'll come back to it if we feel like we've got more time, because I kind of want to show the setup of all of this, and then we could kind of leave filling out the rest for kind of like a take-home activity for everybody to look through and see if they can match the spreadsheet where this has already been set up. So this is so in this column Q, this would be where the situation where the benefit previously ended. So this is a situation where the person had a benefit end, but the benefit ended before 2018, or before this person before this person's age 64 band or something to that degree. So This is a little bit simpler than what we've looked at in the past. One thing we do have to be careful of, though, and this is when you this is one of those situations where you have to think a little bit about what data you received and how you might handle a bad situation. I'm just going to temporarily insert a column here, but let's try this. So I'm going to say if, or if not, sorry, I'm getting my coding languages confused. So if E2 is not blank, and E2 is less, if you have a benefit end date that's actually less than the date of retirement, you kind of have to consider what's our meaning going to be here. So this will say true, false, and see if this actually happens for anybody in the file. Oh, got a typo there. Excel doesn't like when you type things wrong. All right, so just by doing this quick check, yeah, it looks like it is the case for a couple people in the file that wound up with a benefit end date prior to the date of retirement. This is a situation where you've got to kind of think about how you want to handle this. Um, one way to think about it is just maybe this is a bad benefit end date. Maybe this is from like a previous annuity period. It ended for the person, and then they got a new annuity, and then this date just stuck on the record, which is possibly the most likely scenario. Another possibility is you could think that you could decide that this person this is just bad data and that this person should be kind of thrown away. It's unlikely, by the way, that this person would be present on any sort of annuity register if they weren't actively receiving a payment. It's pretty easy to tell who's still collecting a benefit if you're an administrator of any sort of annuity. So I would lean more towards thinking, and this is not the correct answer, by the way. This is just an assumption that you should make and document when you're performing your experience study. But I would say my assumption personally would be that the end date is old and does not apply, and that this person is currently still receiving an annuity. It's just an assumption. Clearly, it's only a couple of records. It's not going to massively distort our study one way or the other. It's just trying to rationalize making a decision, documenting the decision, and not taking such a big leap of faith that you think you're jeopardizing the accuracy of your results. If you wound up getting a data set like this where this problem was persistent for a much bigger set of records, this would be a situation where you would want to take that, go back to the contributor and try to understand what is this benefit end date? Why is this here? What is it telling us when the benefit end date is before the date of retirement? All right. So just kind of operating under the assumption that benefit end dates prior to the date of retirement are not going to be taken into account for for a benefit that has previously ended, or sorry, for a benefit that ends during the period. So we'll say if the benefit ends during the period, a few different conditions have to apply. So you need to have the retirement date needs to be less than or equal to the end date, because we just established that we do not want to count the end date if it is prior to the date of retirement. We want to make sure that the end date for the benefit to end, it has to take place during the 2018 time period while the person is still this age. So it has to be less than the birthday. And it also has to be within 2018. So it has to be greater than or equal to our January 1st date. So then I think that's the condition right there, is if we have a benefit we we have a benefit end date. We know it takes place within this specific time period. I know we're not checking in this function that it's a blank, but it can't be a blank and satisfy these conditions, so I don't think we need to. And then I think that to do this, then if the benefit ends, our exposure winds up being the fraction of the year between the retirement and the end date and unless in the very large amount of cases that the date of retirement is prior to 2018. So we're going to cap that at the fraction of the year elapsed in 2018 prior to the end date. And I've entered too many arguments for the function. Well, goodness me, where's my mistake? And if anybody sees a problem with what I typed in, feel free to chime in. It's usually some issue with parentheses. Here's my value if false, value if true. This is also a reason why you don't want to do this all in one cell, because this becomes, oh, I typed year instead of year frac. That would be it. Okay, sorry about that, everybody. Just goes to show everybody makes mistakes. So this is our scenario where the benefit ends, and you see a lot of blanks here. This is kind of a rare situation. So why don't we just try to filter on a situation where we have benefit end dates in 2018 and just try to observe what this looks like when we have a benefit end date that takes place during the first age. So this person doesn't count because they were born early in the year. So this would be a good example here. This person has a birthday in November, but their benefit ends in September. So this should return for us the fraction of the year between the beginning of the year and this where's this September 13th, and it looks like that's exactly this might be considered exactly 70% of the year by the year frac formula. It's kind of interesting. So that's what pops out here. And then you can see for the other cases that have an end date in 2018, sometimes it hits here, sometimes it doesn't, because that date is actually because the event date takes place after the birthday. All right. So now let's talk about the case where the benefit ends prior to the period. This one is a little bit this is a little bit easier than the previous one because we're not looking to calculate any exposure for these people. If the person hits this condition, it's just a zero, right? So what are the possibilities here? So this would be a situation where either the end date is prior to the date of retirement, or the end date is, let's see, what do we want to say here? So the benefit ends, if the benefit ends prior to January 1st, 2018, this would be a situation where either the person is deceased prior to 2018, or the benefit ends during 2018 and the end date is actually after the date of retirement. I think those would be the conditions, because remember, we have the situation where we're kind of ignoring the end date, and that might wind up in a different place. So just to make sure that we've covered all our bases and we're not having more than one thing fall into different columns, we'll assume real quick that we'll assume that condition has to apply as well. So all right, so we already typed our if. So let's see. So our possibilities are either the date of death is less than our beginning of the year. That's one possibility for the benefit to have ended. And if the person is deceased prior to then, we don't really need to do a bunch of other checks on that, because the date of death is the date of death. It's pretty unlikely that dates of death are recorded incorrectly, but we know that there's no way for an annuity to begin again after a death. So we can kind of take that at its word. Oh, whoops, that's not right. Let's see. So we got that. So, or if either this happens, or this is a little trickier with the date that the benefit ends. We want to check that it's less than January 1st, 2018. But we also want to just double check also that it is greater than the that it's greater than the date of retirement. Because remember, we kind of made the decision in that other column that we want to ignore situations where the benefit end date is before the date of retirement. So somebody's benefit could be active, and just because the benefit end date is before 2018 doesn't mean that it actually ended a benefit if the retirement date actually takes place after the the retirement takes place after the benefit end date. All right. So those are our two possibilities, and if if those are satisfied, then we will say this person gets no exposure because the benefit ended and prior to the period where we're measuring. All right, so we got a couple of zeros that we can see, and it's nice. It kind of fits into the columns where, the rows where we might have thought. This is an example. This person has a date of death in 2017, so they have no exposure. Believe this person was winding up with a zero as well, and then another one down here in another death date in 2017. So that seems to be working properly. All right. We are at, let's see, we got about 15 minutes left. I think what I will recommend, I think we're going to try to wrap up this exposure age 1. We can leave the exposure at age 2 as a take-home exercise. It's a little bit of a nuance to it, but I think with this structure already set up, it should be something that you can kind of take and do and figure out. So I think that the other items that I want to do is show how to kind of check our work on this after we've set up all the columns. I want to show how to set up this death exposure for this age 1. And then we'll talk a little bit about some tricky records that we have not that we've not gone through yet. So there's a few that I've kind of planted in here that can cause issues. All right. So exposure age 1 as where there is a situation where there is a death. So a lot of conditions need to be met in order for us to consider a record a valid death. So let's set this up with an and, because the date of death needs to satisfy a bunch of criteria. First of all, we need to have the person retire prior to their birthday in 2018. I think that's because if we're tabulating exposure at all for this period, that I think is kind of a no-brainer there. We need to make sure that the date of retirement is less than the date of death, which typically it should be. You may find some problems in your data where the date of death is actually prior to the date of retirement. We may look at that in just a little bit, but that's another thing to look out for, just to watch out if something looks bad like that, because it's unclear that you would want to actually tabulate exposure for a person with a date of death before their date of retirement. You know something is wrong there, and it's not entirely clear what. The date of death also needs to take place before the birthday, else it's not in the requisite range. You need to also look out for the situation where the benefit end date is between the date of retirement and the date of death, because that would represent a situation where the person's benefit had ended and we're no longer observing that person. So that would be the situation where the end date is after the date of retirement and the death date is after the end date. All right. And then our final condition here will just be that we already checked to see that the death date is less than the birthday. We also have to check whether the death date is actually in 2018 at all, and that'll take care of that there. So I think that's our list of conditions. It's quite a bit. I hope it's not overwhelming, but it is a pretty long list. So then we have to figure out what is our exposure for somebody who dies during the year. And I think what we discussed yesterday is that in the event of a death, the person's exposure continues until their following birthday, regardless of when that death takes place. So if we have a situation where a person dies, we don't want to cut off that exposure at the date of death. We want to finish off that age band. So we want to take the most that somebody could have, the most let's see, we got that. Let's see. So in the situation where the person was retired prior to 2018, retired prior to 2018, we would want to give exposure between the birth date, and it doesn't matter what order you put the dates in. I know it's a little backwards. It's not going to output a negative number on you. Between the birthday and the beginning of the year. And if otherwise, there could be a situation that if that actually is a longer period of time than they were actually retired, because remember, we don't extend exposure back to the beginning of the previous age. It can only go back to when you actually are being observed, when you actually retire in this case. So that would be the difference between the date of retirement and the birthday. And then I think that's it. Oh boy, what did I do? What did I do this time? Help debug Patrick's formula. Oh, I did it again. Huh. Old habits die hard, I guess. All right. All right, so let's see what this looks like. I'm just going to filter on the records that for which this is coming in as something other than a blank. All right, so these will be our death records. And I kind of want to see what happens when somebody has a date of retirement during 2018. Here it is right here. So this person, I think normally, you see when you have somebody retired before the year, they would get exposure, through their birthday. This person here retired in May and passed away in July. So they're not getting this. This would be normally like, just like about a month and a half of exposure. But this person's getting exposure through their birthday in December. So this is going to be, oh, did we not do that right? Huh. Did I put the wrong letter in there at the end? Oh, wait a minute. What am I? Oh, yeah, I did put the wrong letter in here. This should have been an M. Yeah, because they get exposure from the retirement date to the birthday. Kudos to anybody who saw that that didn't speak up but was just waiting for me to find it. Nice job. All right. So looking at this, let's go back to that person because I definitely had the wrong number in there. All right, so this person gets exposure from May all the way through their birthday on December 15th, which is a little bit over a half a year, and clearly greater than clearly greater than just the fraction between these two. So we can figure that that's working properly now. All right. So I think I mentioned that all of these conditions should have been designed to be mutually exclusive. So we're going to go ahead and perform a check on that. We are going to say, here is, we've got our 5 columns. We think that this is accurately creating a situation where everybody falls into one group and we're calculating exposure for that for them according to the rules of that group. So this is how I would go about doing that. So we just check to see in succession if each one is blank. And in each component of this, if it's blank, it's going to count for 0. And if it's not blank, then it's going to count for 1. And ideally, when you do this sum for each, when you do this sum, you should find that every single record should have a 1. If not, there's probably something amiss and something that's worth looking into to see why somebody's hitting multiple conditions or why somebody's not hitting any condition. All right. So let's go ahead and copy that down and we'll put our filter on it and see what options we have for column S. All right, well, we've got everybody has 1 except this one person with a pound value. And I think that the issue with the pound value is that this person has a pound value for their date of birth. Ultimately, this is not a person whose experience we are going to want to include in this study. just because if they don't have a valid date of birth, it's impossible to tabulate their experience to a particular age. So this is where formulas would benefit from doing something with like an if error. And you can I don't think it's necessarily required for the ages, but for the other columns that you're trying to sum up, there is definitely a benefit um, to putting an if error condition on there, so that when you try to sum up a full column, you can actually see what the sum is and just use a zero for that person or something. So that's something that could be added to all of these fields, so that we don't, if you try to sum it down like this, usually at the bottom of the Excel screen, you can see what the sum of your column is. You can't see it here because there's a pound value mixed in there. So if you were to fix that one record, that would be what could take care of that problem. Um, and then I think that I want to look at a few of the trickier records in there, and maybe we could think about how they're being treated. So I kind of have a few plants in here as being a little sneaky. Um, let's look at some of these folks. So this one, I don't know if there's anything magic to this besides the fact that they died before their date of retirement. So this person is coming through with yeah, the benefit had ended because we put in a condition for that. But when originally setting this up, this was a situation where this wasn't flowing through the right place because I had not tagged it with that condition. So that was just something that that was worth observing. Um, this one right here, we have somebody where the benefit ends prior to the date of retirement. I think we already looked at that. That person not getting any exposure for age one, but theoretically, if we set up these formulas properly, that person would get exposure for age two. Here's another one where we have a benefit end date prior to the date of death. This would be a situation where um, we would expect there to be a death if that benefit had not ended, but it seems to be flowing through our previously ended check because this is meeting the criteria where the benefit end date took place after the date of retirement, but prior to our observation year. All right, 3390 is just the person with the missing birthday. And then this is, I think we would get into this in the second if we were to go through and do exposure age two, but maybe I'll just talk about this real quick. This is a situation where we've got birthday of January 1st, and then we have a retirement during the year, and then a death during that year. And this is probably the trickiest scenario you could possibly have, because typically for deaths in the second half of the year, if the person was already retired on their birthday, they would just get an exposure of one. This person is going to get exposure from their birthday or from the retirement date of April 25th all the way through January 2nd of 2019. So this will be a situation where there actually is a fractional fractional exposure for the person for age two. Most of the death records for age two will just have a one. All right. So I think with that, I want to bring up something else that I had done in the solution spreadsheet, which you will see. And by the way, if you come back, this is the first time that we've actually run this training. I didn't really know much about how the length would play out, or I haven't had this looked at by anybody but myself. The only checks I really have on there are the ones that we talked about during the session. But this is kind of how this works: is that you can figure out the amount of exposures and deaths at each age using this SUMIF function. Basically, for the SUMIF, you tell it what column you want to sum, and then you tell it what criteria range you want to look at. So in this case, we want to check to see if the age column is equal to 51. So this is our criteria, B5. And you can kind of sample and see how this works. But SUMIF is a very useful formula to perform aggregation for experience studies. And I know that it's probably something we didn't have time to go through today, but I did want to just illustrate that in the forthcoming solution spreadsheet, this will be in there, and you can see how everything is tabulated. All right. So I think from here, maybe as a take-home exercise, you can kind of see that in this, expanded this out to exposure age 2, did a lot of the same checks in there, measured the exposure for each record. I think that when you receive this is kind of how, at least if you proceed according to the method that I've laid out, this is maybe how this might look for exposure age 2. So I'd encourage everybody to go through these possibilities for the second age as an exercise, and try to come back and figure out what the total exposure at age 1 and age 2 is for each individual. I think I have the sum if formulas and the solution kind of already set up, so you could probably even borrow this structure to try to match up these values against what's coming out of your spreadsheet, and then I think that will be that'll be the exercise. Feel free to reach out to me with emails if you notice something that might be amiss, or if you're having trouble with a piece of this. It's just pnolan@soa.org. That's PNOLAN at SOA.org. Certainly would be happy to hear your feedback and help you out with any place where this might be confusing. And I think that's about it. Do we have any last questions from the group? All right,
Thank you,
Sally, hearing
Patrick.
nothing.
For another great session. You went through in a lot of detail, and I think that this really gives students really good starting point to understand how it's done, and then they can take it from here. I think you've led them almost to the end. We'll be sharing the solution early next week, just to give everybody a little bit of time to digest this, rewatch this video, which will be released if they have trouble following along, and then just try to solve them on their own. And as Patrick offered, if you do have any questions, comments, he'd be happy to address anything. So thank you again, Patrick. I'll say thank you for the students who are in attendance and those who will be watching our video later. Hopefully you find this useful and can do this on your own and get some hands-on experience, and those will be very useful for the future projects. Great. So with that, we'll end the session, and thank you again for everybody for attending. Have a good night.
Thanks, everybody. Have a good night.